Okay, welcome to another example of the one that we just did previous. You can see I still got the answer there, 2i. So this time it's saying z is a complex number such that the real part of z equals 2 times the imaginary part of z. And z squared minus 4i is real, so we have to find z. Okay, so let's go through these steps. Let's just start off with writing, with let z equal x plus I, y. Now, the real part of z, okay, the real part of z equals x and the imaginary part equals y. And what they're saying is that the real part of z equals 2 times the imaginary part. So x equals 2y. So we can write the complex number as x equals 2y plus iy. Okay, so just leave that for the end part. Now, z squared minus 4i is real, so let's find z squared minus 4i. First of all, let's find z squared, okay, from here. So what do we get? We get 4y squared, okay, plus 4iy squared, okay, plus I squared y squared, okay. What do we get from there? Well, this I squared turns into a minus 1, so we can group it with, so 4y squared minus y squared plus 4iy squared. So that's so far z squared. Now, if we subtract 4i from both sides, we're going to get this. So we subtract 4 from this side, sorry, 4i, and we subtract 4 from this side, so 4iy squared minus 4i. Okay, we end up getting 4y squared minus y squared plus I 4y squared minus 4. So that's the complex number z squared minus 4i. Now, we know this part is real. So that means the imaginary part doesn't exist or equates to 0. So that means 4y squared minus 4 equals 0. So 4y squared minus 1 equals 0. So y equals plus minus 1. So what does that mean? That means if we take y and substitute it back in here, we actually have two complex numbers that meet this criteria. Okay, so when y is 1, we get 2 plus I, and y is negative 1, get minus 2 minus I. So they're our solutions to this question. So a little bit more difficult, but in the end you can see the steps are quite easy and you should go from there.